We have seen how we can make the before image available in the supplemental logging data. Let's see how to configure the parameter files for conflict resolution. Those are the parameters that you use to configure the CDR. The first parameter is the log all subcalls for Oracle Golden Gate Release 12c or Git Update Befores for the older releases. The target of those parameters is to capture the before image values and add them to the trail files. This is the default behavior in Oracle Golden Gate 12.2. Get before calls is actually an option in the table parameter, and it is used in the extract process parameter file. You use this option to specify which columns to be included in the before image data. However, if you use the log all subcalls parameter, you don't have to use this option. The before image of the supplementally logged columns will already be captured in the trail files. Compare calls is an option of the map parameter which is used in the replica to process parameter file. Use this option to define which columns to be used for detecting update and delete conflicts. Finally, you use the resolve conflict option in the replica to process parameter file to specify how to resolve the detected conflicts. Get before calls is an option of the table parameter used in the extract parameter file. This option is used in Oracle Golden Gate version 11G and older. You use it to specify the columns that you want the extract process to capture their before image values and save it in the trail files. Oracle Golden Gate 12c provides the parameter log all subcalls that I talked about in the previous slide. If you use it, you can omit using the get before calls option. The example in the slide is showing how to instruct the extract process to capture the before image values of the columns quantity and description in the table. The values of the key columns and the updated columns will automatically be added. With the compare columns option, you specify the columns that will be used by the replicate to detect the conflicts. It supports only scalar data types like varchar2, number, and date. Similar to the get before calls option, you define a set of columns for either update operations, delete operations, or both of them. And as in the get befores option, you can define all the columns, specific columns, only primary key columns, or all the columns except specific columns. I will show you some examples in the next slide. The extract uses the before image values of the quantity and description columns to detect the conflict on the update and delete operations. In the second example, the extract uses all the columns except the comment to detect the conflicts on update operations. On the replicate side, you use the resolve conflict map option to specify how the replicate will respond to the conflicts. First, you define the conflict type. As you see in the syntax, you can define 5 conflict types. They are insert row exists, update row exists, update row missing, delete row exists, and delete row missing. They are corresponding to the possible conflicts that could take place in the target database. Use a resolution name as a name for a specific column group that is linked to a specific resolution type. Supply a name that identifies the resolution type. If you want to define a resolution role to all the columns that are not in an explicitly named column group, use the default keyword. This will be clearer to you when you see example later in this lecture. Finally, you define the response of the specific conflict. You have a list of responses to select from. I'm gonna explain about them in the next slide. Don't be horrified by the complexity of the syntax. When you see examples of using this option, it will be very clear to you. This is a list of the conflict resolution methods that you can configure in the resolve conflict parameter. The first row is actually a short term for the methods useMax, useMaxEq, useMin, useMinEq. If you use, for example, useMax method, the replicate process will check the value of the given column in the updated record. If the value of the given column in the trail record is greater than its value in the database and the conflict was insert row exists, the replicate will apply the trail record and change the insert to an update to avoid a uniqueness violation and overwrite the existing values. Use delta resolution method is used if you want to update the current record with the value of the difference between the before and after image values. This is only possible as a response to the conflict update row exists. If you specify the discard method, the replicate will write the record in the discard file and will not apply it. The overwrite option makes the replicate apply the record in the target database. With the ignore option, the replicate will not apply the record, and it will not either write it in the discard file. Not all the resolution methods can be used with all the conflict types. This table shows you what are the possible resolution methods that can be used for the specific conflict types. Logically speaking, this makes sense. For example, overwrite resolution method can be used with all the conflict types except the delete row missing conflict. The table also shows you what will be the effect of using a specific resolution method with a specific conflict type. For example, if you use the overwrite method with the update row missing conflict, the replicate will change the missing update operation to an insert operation to apply the record in the target database. I will show you now examples of using the resolve conflict option. In the example that is shown in the slide, the compare calls option uses the before image of all the columns in the trail record to detect the update or delete conflicts. Because the default keyword is used, the replicate process will use all the columns as the column group for all conflict types. Thus, the resolution applies to all the columns. For an insert row exists conflict, use the useMax resolution. If the row exists during an insert, use the last mod time column as the resolution column for deciding which is the greater value, the value in the trail or the one on the database. If the value in the trail is greater, apply the record but change the insert statement to an update statement. If the target database value is higher, ignore the record in the trail file. The same applies for an update row exists conflict. If the row exists during an update, use the last mod time column as the resolution column. If the value in the trail file is greater, apply the update. Otherwise, ignore the operation. For a delete row exists conflict, use the overwrite resolution. If the row exists, but it's different from the current record, apply the deletion. For an update row missing conflict, use the overwrite resolution. If the row does not exist during an update, change the update to an insert and apply it. For a delete row missing conflict, use the discard resolution. If the row does not exist during a delete operation, write the trail record in the discard file. In this example, the replicate will decide about the conflicts using the values of the primary key columns plus the columns phone, salary, and last mode time. For the update row exists conflict where a target record exists on update, but non-key columns are different. Use two different resolutions depending on the column values. For the salary column, use the use delta resolution logic so that the change in the value will be added to the current value of the column. For all other columns in the table, use the last mode time column as the resolution column. If the value of the last mode time in the trail record is greater than the current value of the same column in the target database, the changes are applied to the target database. This example uses all the columns except the comment column as the comparison columns for conflict detection for update operations. For an update row exists conflict, use two different resolutions depending on the column value. Use the use delta resolution logic for the salary and balance columns. Use the use max resolution column for the address and last mode time columns. The last mode time column is the resolution column. Use the ignore resolution logic for the remaining columns in the table. Changes to these columns will always be ignored by the replicate process. That's all about configuring CDR rule in Oracle Golden Gate. Simply, when you configure the CDR, you define the conflicts that could happen in the database and how Oracle Golden Gate should respond to each of them. You will implement CDR practically in the next practice lecture. See you over there. Thank you very much.